Hello everyone, welcome to Trig Review Day 2. Today we're going to talk about special right triangles. All right, so our goals for today, we want to review special right triangles. We want to use the special relationships in a 45, 45, 90 right triangle to solve for missing sides. And we also want to use the special relationships in a 30, 60, 90 right triangle to solve for missing sides. So back last year in geometry, you might remember these triangles, the 30, 60, 90 and the 45, 45, 90 right triangle. So to help refresh your memory, what I'm going to do is I'm going to show you where these special right triangles came from and then establish those relationships one more time for you. All right. So the 30, 60, 90 right triangle comes from an equilateral triangle. All right, so this is equilateral, and let's pretend that this triangle has side lengths of 2. All right, so we're just going to say that all the sides here have a side length of 2, right? And that's kind of what makes it equilateral, right? An equilateral triangle has all sides that are the same length. And so one of the other things that we remember about the equilateral triangle is that all of the angles inside of the triangle are also the same, right? So this angle right here is going to be 60 degrees. They're all going to be 60 degrees, right? Because if you remember, all the angles in a triangle have to add to give you 180. All right, so the 30, 60, 90 right triangle actually comes from taking this equilateral triangle and splitting it in half this way. All right, so if I take my pen here and I cut this triangle in half, we get our 90-degree angle right here. And because I cut this angle in half up here, we get a 30-degree angle. All right, so there's our 30, 60, 90. All right, that's why they call it 30, 60, 90. It's based on the angles. So what I'm going to do is I'm going to take this half triangle right here, right? This half of the equilateral triangle. I'm going to pull that out of the diagram and redraw it down here. All right, so there's my 30, 60, 90, and then I'm going to try and put as much information about the sides that I have. So remember, this side right here, the hypotenuse of the triangle, came from this side right here in our equilateral triangle, so its length was 2. Now remember, the bottom part of this triangle, this bottom side down here, that was also a length of 2, but since we cut it in half, that means half of the triangle is going to be 1. So we know that this is a 1 down here. And the only remaining side that we don't know, let's call it x for right now, is this side over here, and we can solve for that side using the Pythagorean theorem. Okay, so I'm going to take one of the legs, I'm going to say that's a leg, right? 1 squared. The other leg is over here, that's x. So I'm going to say 1 squared plus x squared must equal the hypotenuse squared, right? So that's going to be 2 squared. So then I do a little bit of simplifying here. So I've got 1 squared, which is 1, and then we've got x squared still here, and then on this side we get 2 squared, which is 4. All right, and then again, my goal here is to solve for x. I want to figure out what this side of the triangle is, so I'm going to subtract 1 from both sides, and the 1's cancel, so we get x squared equals 3, and then to finish this off, I'm going to square root both sides. Okay, so we get x equals root 3. So this side is root 3, and I'm going to go ahead and put that into my diagram here because I'm going to be using this diagram later to help me with these problems down here. Okay, so there we go. Now, just for future reference, this side down here, this 1, we call that the short leg. This one over here we call the long leg, and this one we call the hypotenuse. Okay, so just for future reference, so if you ever hear me refer to the short leg or the long leg, you know what I'm talking about. All right, so that completes our 30, 60, 90 right triangle. Now let's do a 45, 45, 90. Okay, and the 45, 45, 90 actually comes from a square. Right, so this is a square, which means all of these sides are going to be the same. So let's pretend that they all have sides of 1. So this is a square with sides of length 1, and I'm going to split this square in half, just like that. Right, and you'll see that 2 triangles form here. All right, now also recall that in a square, right, all of the angles are 90 degrees. So this angle, this angle, this angle, and this angle, they're all 90. But since I cut this in half, this is going to be 45. And this is going to be 45. Okay? So you see your 45, 45, 90 right triangle form inside of the square simply by cutting it in half along its diagonal. All right, so I'm going to redraw that triangle down here just like I did for this one. Okay? So there we go. We've got our 45, 45, 90. I just wanted to remove it from this diagram so that we're focusing on just the triangle here. So this side was 1, this side was 1, and the side that we don't know here is the diagonal. So we're going to call this one x, just like we did in the 30, 60, 90. And our job here is to figure out what x is. And to do that, we're going to use the Pythagorean theorem. All right, so the legs are over here. And notice that the legs are the same length, right? They're both 1. So we're going to say 1 squared plus 1 squared equals x squared. Okay, well, 1 squared and 1 squared, well, those are both just 1, so it's really just 1 plus 1 equals x squared, and then 1 plus 1 is 2, so 2 equals x squared. And then to finish this off, I'm going to square root both sides. Right, so we would say the square root of 2 equals x. So I can come over here to my diagram, get rid of this x, and I'm going to put in square root of 2. And like I said, I'm going to use this diagram to help me out with some of these problems down here. I'm going to show you how to do that real quick. So now we have looked at where the 30, 60, 90 right triangle comes from, where the 45, 45, 90 right triangle comes from, and we see how those are extracted. Now let me show you how we use those. And so here we have a triangle, and upon inspection, I notice we have a 90-degree angle, we have a 30-degree angle, and since I know all three angles have to add to be 180 degrees, I know that this has to be a 60-degree angle. So I immediately recognize this is a 30, 60, 90 right triangle. I know one of the sides, and I need to find the other two sides. Okay, so you might recall from geometry that if we have a triangle that is similar, right, and we know that they're similar because the angles are the same, right? All of the angles are the same measure, so they are similar triangles. What that means is that the sides are proportional, right? So for instance, this side, the short leg, was 1, but in this triangle, the short leg is 10, right? So if I'm looking at the shorter leg here, its length is 10. In our original triangle, it was 1. So what that tells me is that this triangle is 10 times bigger than this triangle that I was using up here. So to figure out the other two sides, right, x and y, I can take this triangle that I had up here and just multiply the sides by 10. So here's the hypotenuse, right? This is x, the hypotenuse. Now in this triangle up here, the hypotenuse was 2, but remember it's 10 times bigger. So if I just take that 10 and multiply by 2, now I know the hypotenuse here is 20, right? Because 2 times 10 is 20. And I can do the same thing with this side, right? In our original triangle, right, the original 30, 60, 90, the long leg is root 3. So all I have to do is take root 3 and multiply it by 10. So we get y equals 10 root 3. And now I know all three of my sides. And I didn't have to do this. That's the beauty of it, is I didn't have to do the Pythagorean theorem. I just used what I know from this 30, 60, 90 right triangle and applied it to this one. Okay, so it's kind of a shortcut, and it makes solving these kinds of triangles much, much easier. And the other nice thing is we don't have to know two sides. We only need to know one. Okay, so let's try it again. This time on a 45, 45, 90. Now remember, here's our original 45, 45, 90. These had legs with length 1. This one has a leg of length 4. Right? So that means that this triangle is 4 times bigger than this triangle. Okay? So this side, we don't know, but you know over here it was 1, right? But we're multiplying it by 4. So we know that this one has to be 4. And we also know that because we know these two legs have to be the same. Okay? Now, this one was root 2, but we need to multiply that by 4 first, so we're going to say 4 root 2. And that's how easy it is to solve for the sides of a right triangle if we know that it's one of the special right triangles. All right. One more time, let's see if we get this down here. So we have 60, 90, which means this one has to be 30. All right, so we do have a 30, 60, 90 right triangle. Notice the side that they're giving us the hypotenuse here. Okay, so the hypotenuse is 6. Well, in our original one over here, it was 2. So 2 times 3 gives me 6. So this triangle is 3 times bigger. Okay, so I'm going to go to the short leg first. Okay, my short leg in the original triangle, in the original 30, 60, 90 was 1. So if I do 1 times 3, that means this is 3. Okay, And then same thing over here. The original 30, 60, 90 was root 3, but I got to multiply by 3, so x is going to equal 3 root 3. All right, and you can leave your answers just like this. Just leave it in, this is what's called radical form, right? Just leave it with the square root. This is our exact answer. Okay, so you can leave your answers in exact form for these, and that makes these problems super quick. All right. Okay, guys, go give it a try in the practice problems and let me know if you have any questions in the Zoom chat. Have a great day.